Hello, this is Mr. Dutta, and I'm going to go through the Mini Earth booklet. So as I go through these, I'm going to uncover these notes, and then you'll just copy them into your booklet. I'll also offer an explanation as to the information you're putting in there. Most of the information we're putting in this book we should have already covered, but this is just highlighting the more important information. Okay, the first thing is that there are two types of crust. It's either oceanic or continental. So one of the things you need to realize is that oceanic and continental crust, obviously the continental crust makes up the continents like North America, South America. Oceanic crust is basically the ocean floor. The continental crust is thicker and the oceanic crust is thinner. You can also tell this by looking at this image. According to this graphic, the continental crust is way thicker than the oceanic crust. You do have some overlap right here as indicated by this graphic, but for the most part the oceanic crust is thinner. Continental crust is the thicker of the crusts. Continental crust in general is made mostly of silicate rock. Silicate rock are those rocks that contain silicon, or the element silicon. The last note for the Earth's crust is that the lithosphere is partially located here. If you remember, the lithosphere is a combination of the crust and part of the upper mantle, but you would consider the lithosphere also being part of the crust. Also remember that the lithosphere is where the tectonic plates are formed, or where they're found. And here you see just a picture of all the existing tectonic plates. But this would, in the crust, this is also where those plates are located. Okay, moving on to the upper mantle, our first set of notes. Remember the upper mantle, or the mantle contains the slow-moving asthenosphere. Now in the asthenosphere, you do see this convection type movement. Remember, we've covered convection before. This is where liquids undergo a movement based on their temperature, where the hotter liquid will move towards the top and the not so hot liquid will sink towards the bottom, and this sort of process continues over and over, causing motion in the liquid. So the asthenosphere, it does undergo convection. The next note, the mantle is also the largest layer. So out of all the layers, the mantle is by far the largest. And as I mentioned in the last slide, the lithosphere is also located on this slide. It's part of the upper mantle. So together, if you look at the crust and the upper mantle combined, you would consider that the lithosphere. Okay, moving on to the outer core. There's not too many notes for this section. I did want you to know that this is the only layer of the Earth that's entirely liquid, and it has to do with the depth of the layer, the amount of heat present, the amount of pressure. This layer of the Earth actually exists as a liquid. It's made mostly of iron and nickel, which are both metals. And you're going to find these notes similar to the inner core. The inner core is actually a solid. It's under a lot of temperature, which make you think it would melt and be in liquid form. But since it's under such pressure, the liquid acts as a solid, so we consider it a solid. Same thing. The inner core is also made of nickel and iron. It is actually the metal components, or the metal parts of the core, that cause the creation of the magnetosphere. The magnetosphere is kind of what it sounds like. It's a magnetic field around the Earth that's generated because the iron and nickel core of the Earth is actually rotating. The outer core spins one direction and the inner core spins the other direction, and that combined effect kind of creates this magnetic field, kind of like the force given off by magnets. So it's the same force. We are thankful for this magnetic sphere because it is that field that keeps some of the more harmful solar radiation from getting to Earth. So you can kind of see in this graphic right here how it has this kind of deflecting force that keeps these harmful sun rays out of Earth and away from us. In fact, scientists hypothesize that at one point the planet Mars used to have a magnetosphere, but a long, long time ago, for whatever reason, we still don't understand why, it's lost its magnetosphere, and since it had nothing to protect itself from the sun's radiation and waves of energy coming off the sun, it slowly lost its atmosphere and became the planet that it is today. So that's just kind of a little extra there for those of you guys who are curious. But that's the end of these notes. If you missed anything or if you want to hear something re-explained, feel free to rewind and check it out. If you have any additional questions, you can always find me. Thanks.